And welcome to the next video in a series of augmented reality image tracking. And this time we're going to tackle Three.js and the WebXR image tracking. Just beforehand, as a quick note, as you can see here, the WebXR image tracking, I'll just make the text a little bit larger, is in draft. So there may be a strong possibility that this functionality will be changed. I mean, the way it's implemented and it will be used will be changed. So I do not recommend to build productive applications with it, but it's enough to play around at least. And there is also a very short example here how you can use it and so on, but we will dive into that in a few seconds. So first of all, I'd like to set up the project, and for setting up the WebXR project, as always, I'm going to use Vite, and I'll guide you through all the setup process. And nevertheless, let's get started. Let's start a new project here and go to the terminal. Just type npm create Vite latest. Give it a name. I'll just call it 3 image tracking. We're going to use vanilla JavaScript. Using JavaScript, then type cd 3 image tracking npm install, and after that is finished, we can run the site with npm rundev or npx vite. And if we're opening the page, we see that everything is set up, the test site is up, and so on. Okay, that's actually working, and let's switch back to Visual Studio Code. Cancel the running site and just open the folder directly. And within this folder, we're seeing that this is a node project, as we all know it, and there are a few folders, and we will just add something now to enable HTTPS, because we're going to run our site again. We see that our localhost site runs on HTTP, and even if we use the --host flag, everything will still run on HTTP, but for WebXR we need HTTPS. So there is a basic plugin. As always, the links are in the description box. For Vite, it's called ViteJS Basic SSL, and all we have to do for this plugin to work is to create a Vite config.js, paste that, and everything will work magically. So let's check out the npm site, copy the npm command, npm install, and create a new file, vite.config.js, and paste everything from the Vite site here. Save it. Now, if we run it again, no, not the npm command, we'll see that everything runs now on HTTPS. So that's the basic setup. And all we need to do now is install Three.js, npm install 3, wait for it to finish, and start preparing. So first of all, we don't need the counter.js file, we can delete that. We can delete nearly everything from the main.js. I'll just make it a little bigger, so I guess it's easier to see for you guys. That's too big. That should work. We can delete everything here and just leave that. And this, we can also delete everything from the style.cs. Nice. So for the rest of the project, just have a look at the index.html. For the rest of the project, I will not type every letter. I will just show you the parts of the code and we'll just like puzzle it together, because watching me type is very, very boring. So first of all, we have our app container here. We will just replace that with a scene container and our images that we want to use for the image tracking. So remove that, insert that, save it. And as you can see, we have here an image for the hero marker, which is a locally deployed image. We'll see that in a moment. And an online linked image from the Earth. I can show you that now. Here is our Earth image for tracking. And our hero marker here is just a very, very simple hero marker, and it's on our local hard drive, and I'll just add it to the public folder. So I'll open that in the File Explorer and insert my hero image here, hero PNG. And the other one is online, so that's not a problem. And that's the basic setup for our index.html. So that's it. We won't have to touch it again if everything will work. And for our style.cs, we're going to add everything that our camera image can be shown. So we'll have to remove all the margins at the scroll bars. And for our scene container, we're just telling the website to take all of the space that's available. That's done here too. And the Vite, we don't need the Vite config at all, so we can straight up switch to the main.js, where I just import everything from Three, import my AR button, and create variables for the camera, the scene, the renderer, and for our meshes, which should be displayed on the markers. And there will be one big async init function, which will be called when starting the application. And as with every great Three.js application, we'll just start very basic. We'll create a new scene. We'll create a new perspective camera. I'll just position it around 5. That's not really necessary, so you can also omit that. Let's just omit that. We'll create a new Three.js WebGL renderer. Set all the basic values, the start values, color space, animation loop. The render function will be created in a minute. Set XR enabled to true. Query our container and add our canvas, which will be created here by Three.js, to our scene container, and create a new ambient light and add it to the scene. So for the next step, we're going to set up our image targets, and as you saw already, they have their own IDs. So okay, it's formatting stuff. There is our image marker hero, which is this ID, and the NFT, which stands for natural feature tracking Earth. Just write it to the console. And now this is a crucial part. We have to create our AR button to start the AR application. Let's go here. So we'll just create the button here, AR button, create button, give it the renderer, and under required features we need image tracking. Please be careful, only the Chrome browser on Android does support this, and you'll have to enable a flag in the browser. Otherwise you will get an error message, but we'll see that in a few minutes. We're adding the tracked images with the variable, the hero map, bitmap, and the image of the Earth bitmap, which are over here. Hero bitmap, Earth bitmap, and we'll use the create image bitmap function for this. This is for the mobile testing optional features, the DOM overlays for testing on mobile devices, and we're going to append the button to our document. As a next step, we want to add geometry to our marker, so the objects we want to see when scanning or when finding the marker. And this will be in our case for the hero marker, a simple box geometry with about 20 centimeters. I'll translate it up about 10 centimeters so that the object will sit on the marker directly. It gets a usual normal material, that's also nothing special. A mesh created out of the geometry and the material will get a name. We'll have to set the matrix auto update to false because our marker will provide our transform matrix, and I'll set the visible to false so that the cube will not stay within the room and will only appear if we scan the marker and then stay in the room. Last but not least, add the marker mesh to the scene, and we'll do the same for the earth NFT or the earth marker in this case, and then we're basically finished. And to see a better difference, this will be a sphere geometry, also with a mesh normal material, will be moved up. And again, creating a mesh, give it a name, matrix auto update to false, visible to false, and add it to the scene. That's the initialization part. And as you see, it's not that complicated. It's actually quite straightforward if you know how to do it. And what we're needing now is the render function for our animation loop. This one. And we're going basically the same way. We're just creating the render function, and I'll guide you through the creation of this. So first of all, we need the XR frame for our rendering. So as we call the render function, there is a timestamp parameter and a frame parameter, and we'll have to check if there is a frame, an XR frame. So the session already here, do we have a running XR application? And if that's the case, we can query the results from the camera by calling the get image tracking results. As you see in the comment, checking if there are any images we track, logging this to the console. And if we have more than one image, you can just loop through the results. And looping through the results is also pretty straightforward. We'll check first of all the image index so we can differentiate between the few tracked images. And then we'll get in the pose renderer.xr.getReference space. And from out this reference space, in this current frame, we'll get the pose without image space and the reference space. So the result, our tracked image, has its own space, and the reference space is from within the renderer. And the get pose function can get us a pose, which basically consists of rotation and position. And this pose will be used to place the mesh on the marker. And we can also create a tracking state if we're still tracking, or if we already lost the tracking. We'll log that to the console too. And if the state is tracked, which means our image is visible, we can basically start to select which image is tracked. And then we'll say, okay, console log, which image do we track? If the image index is 0, so the first image that we added, so this image index is based on the tracked images property of our AR button, and the 0 index image is our marker index, our hero marker, and the image with index 1 is the earth marker. So if the image index is 0, we can set the hero marker mesh to visible, update our matrix from the pose, and yeah, we're logging to the console. The same goes for the earth NFT, image index is 1, the earth mesh is true, and set the pose, the position and the rotation from the pose. And last but not least, we'll have to check what happens if we're not tracking the image. So if the state is so-called emulated, the image tag is no longer seen. I'll just comment it out, that message, because it spams the console. And as with every render loop, we have to call the render function. And for a better effect with changing screen sizes, which may happen due to rotating the screen and so on, we'll just add the resize function here, and we'll just use it for camera aspect, update projection matrix, and the set size from the renderer. So that's basically everything we need to do. Just save it. Just have a look if anything is going to crash. No, it's looking good, obviously. With a style, we have the image, and I'd say we just try it. Let's call npx vite --host. And it's running, and we're just using the smartphone for tracking now. So first of all, before testing, we need to type chrome.-- and in the search window, search input field, type WebXR and set the WebXR incubation to enabled. Without that, we could not test our WebXR stuff. And changing to the next tab, we're told that our connection is not private, although we have HTTPS. We have to confirm that we want to open the site, advanced, proceed. And if we click on the button now, which usually should tell us start AR, the camera feed will start. And we'll see that there is already something happening. And if we're now going to switch to the image, here you see it. So I can drag the paper marker here. And the sphere marker here at the same time. So that's basically it. Thank you all for watching. Hope you enjoyed the video series about image marker tracking. If you want to see more videos like this, like the short tutorials, please feel free to like, subscribe, and comment. Also give the video a thumbs up. It really helps the channel growing, and just post a few suggestions of maybe what kind of framework, XR framework you want to see next, or what kind of prototype you want to see next. I have a few things in the pipeline, so stay tuned, and I guess I'll see you in the next video. Bye.